Alright, so first lesson in geometry will be to understand the basic terms, so that's the vocabulary words and postulates of geometry. The first word we're going to learn is point. A point indicates a location and has no size. So, the way you label a point is you write point A, capital letter A, or just A. Again, these are capital letters. It has no size, but we use a dot to represent it. A line is a series of points that extend forever in opposite direction, without ends, and has no thickness. The way you label a line is line BA, capital letter L, it's the one right here. Sorry, not capital, lowercase letter L, or the symbol for line, two arrows that go forever, and AB. Another thing I want you to know about line is since they're both going forever, it doesn't matter whether you call it AB or BA. You're talking about the same exact thing. The third word is a plane. A plane is a flat surface that extends without ends and has no thickness. So this is a plane. You usually use a four-sided figure to represent it. The way you label plane is you use 3 points, so A, B, C, or a capital letter that's labeling the plane, which does not have a dot. Just one thing about a plane is when you're using the 3 letters, you cannot use letters that are on the same line. So if this was A, B, C, and a plane here, you could have not used plane ABC. You would have to find, you could use 2 letters from that line, but the third letter has to be outside the line. So you could have said A, B, D, B, C, D, anything like that. Segment. A part of a line that consists of 2 endpoints, so again, it ends, and all the points in between. So you can write line segment AB or a line, except instead of arrows, they both end on both sides. Again, like a line, line segments, it does not matter what way you say it, it's AB or BA, it's the same thing. Same segment you're talking about. Array. Array is a part of a line that has one endpoint, so you see that, it's ending here, and all the points of the line on one side of the endpoint, and it goes in forever. So one endpoint, but it goes in a direction forever. You must name array using the endpoint first. So here, if the endpoint is A, so you have to put A first, and the direction it's going second. So end, and then direction. So, or you could use the symbol for array. Again, you see endpoint and direction. In this case, can you flip it to BA? No, because if you're talking about BA, it would be going this way. So it's not talking about the same thing. So for array, you cannot just switch AB to BA. Opposite ray. Opposite ray are 2 rays that share the same endpoint and form a line. So you have ray CB and ray AC, they're opposite rays. So if you think about it, CB and CA. They're opposite rays. They have the same endpoint, but they're going in the opposite direction. Again, you can label it the same way. Remember, C is the endpoint, so it must come first. Collinear points are points that lie on the same plane. So for example, you have a line, and you have A, B, C. So collinear again are points that lie on the same line, and they are points that do not lie on the same line. They're called non-collinear. Non-collinear. Coplanar are points and lines that lie on the same plane. So you have that. You have A, B, and C. These are coplanar. A space is a set of points in 3 dimensions. And a postulate or an axiom is an accepted statement of fact. So postulate, like undefined terms, are basic building blocks of the logic system in geometry. So those are things that you already know are true. There's no proving to why they're true. They're so logical that we accept that they're true. Okay, so we're going to try example 1. So using the diagram, we have to answer the following questions. So the first question is, what are 2 other ways to name QT? So if you see QT, it's right here. So what are 2 other ways to name QT? So one way, so again, a line, you need 2 points. So you use QT, you could have said Q and N. So line, Q, N is another way. You could have also said line, TQ. Remember, QT and TQ is the same exact thing. You can flip them and they still mean the same line. And the last one I wanted to show is, remember, there's another way. Apart from using 2 points, you can use a lowercase letter. So you could have also write line M. You could use a lowercase letter to name a line. So I'm going to erase this. Whoops, sorry. Okay, the next one is what are 2 ways to name plane P? So we learned the first way you can name a plane is by a capital letter without a dot. So plane P, they already took that. And the second way is by using 3 points. However, if you do remember, you cannot use 3 points that are on the same line. So I cannot use Q, R, and S because they're on the same line. It has to be 3 points that are not all on the same line. So I'm going to use, let's say R. Sorry, let me just label it correctly. Plane R, V, S. Whoops. And the second one is plane Q, V, S. So it could be any 3 points on the plane, but they cannot be on the same line. Question C. What are the names of 3 collinear points? So if you remember collinear points are points that lie on the same line. So over here you could have T, Q, and N, or you could also have Q, R, and S. So I'm just going to name points T, Q, and N are collinear. And coplanar are points that lie on the same plane. So over here I have the yellow surface, and if I see I have 4 points that are on the same surface. So R, Q, S, and V are coplanar. Alright, so that is all for example 1. So let's move on to example 2. Use the diagram to name each of the following. What are the names of the segments in the figure at the right? So if you see it, you have DE. If you remember segments end, right? So DE. Or you could also write ED. The order doesn't matter for line segments. Then you have EF. And you also have DF, the longer one. So again, you could have said for number 2, you could have said FE as well. For number 3, you could have said FD as well. Oops, sorry. So I'm going to erase that. So what are the names of the rays in the figure? So remember, rays, you have an endpoint and the direction it's going in. So the first one is ray. Again, endpoint goes first, direction goes second. In this one, you cannot switch. You cannot say FE, it is EF. The second one, I'm going to say, is that way. So starting, it's ending at E and going towards D. The third one, what if I start over here and go that way? So this one I can write it 2 ways. I could say it's the end point is F, so that doesn't change. However, it's going towards E or D. So I could have picked both. It's the same thing. If I write going towards E or going towards D, since it's the same direction, I could have written anything. So I'm going to pick D. However, for number 4, I'm going to say it's starting at D, but it's going towards F, right? So I can decide D, but it's also going towards E, so it doesn't matter if I say DE or DA. Sorry again. So I'm going to erase that. And now what I'm going to do is opposite rays. So opposite rays are rays that have the same endpoint, but they go in the opposite direction. So over here, this is going towards that, and that's going this way. So I'm going to say ray, endpoint goes first, EF, and ray, ED are opposite rays. Through any 2 points, there is exactly 1 line. So that's the postulate. If you think about it, let's draw any 2 points. Isn't there only 1 line that can connect it? Right? Draw an experiment. Take any 2 points. Can you argue that? Can you argue that when you have 2 points, you can make exactly 1 line? Is there more than a line that you can make through it? No, right? So that's something that's an accepted fact. That is a postulate. You can't really, it's so obvious that we just accept it as a fact. If two distinct lines intersect, then they're intersected in exactly 1 point. So again, 2 separate lines intersect, you only have 1 point that they're connected. Try drawing any kind of line that 2 lines cross, it's always going to be 1 point. 2 lines cross, it's always going to cross at 1 point. 2 separate lines. Again, we're not talking about infinitely many solutions, right? Okay, so I'm going to end this video and we're going to continue the lesson in the next one.